Welcome everybody. In this lecture we will show how electric vehicles can be of great value to the power system. In fact, in future power systems with a high share of renewable energy, there may be a truly symbiotic relationship between electric vehicles and renewable energy sources. Electric vehicles are flexible because of an obvious characteristics. Most of them do not necessarily need to recharge every day. We will illustrate this with a simple calculation. In most Western countries, the average daily driving distance is roughly 30 kilometers per day. In fact, the vast majority of cars drive less than 30 kilometers per day. A typical electric vehicle battery has a capacity of 24 kilowatt hours, which gives a range of roughly 120 kilometers. So, on average, an electric vehicle needs to recharge every 4 days, which gives a lot of opportunity to shift the electricity demand. Well, this may seem very obvious from an electric vehicle perspective, but remember that almost all electricity demand is inelastic. This means that the demand for electricity is insensitive to price. People watch television when they want, and they cook dinner around 6 o'clock, in the Netherlands at least. The ability to shift electricity demand in time has inspired many researchers, including myself, to look for clever ways to use this flexibility. Today we will scratch the surface of this topic, but those of you who are interested can find much more information in the scientific literature. Let's briefly look at what a power system looks like. Electricity is generated by power plants and then transported through the transmission system to the end users. The part of the power grid where the end users are connected to is called the distribution network, which we will look at today. About 10 years ago, when the first electric vehicles started to appear on the roads, distribution network operators were getting worried that a massive adoption of electric vehicles could lead to huge costs of network reinforcements. The figure on the slide shows how the average household demand, the blue line, will increase if 50% of all households owns an electric vehicle and charges it once per day when they come home from work. This is the red line, and we see that it's a significant increase in peak demand, and probably a lot of cables and transformers need to be replaced by heavier ones. But wait a minute. Earlier in this lecture we saw that there's plenty of room to shift the charging, so why not do this at night when household demand is low? The green line shows the resulting demand profile when electric vehicle use as much as possible the night to charge. Indeed, the peak demand has now hardly increased at all. In a study we did with one of the Dutch network operators, we looked at how much money could be saved by smart charging and found that it would lead to a reduction of 20% compared to the normal charging scenario. In fact, in the smart charging scenario, the total network costs are only a few percent higher than in the case without any electric vehicles at all. Now, if we look at the power system on the national level, we see that if 25% of all vehicles are electric, this has a significant impact, even on the electricity demand of an entire country. The top figure shows the normal charging scenario again, when people recharge after they come home. But like the case on the previous slide, here too, we see that it matters a lot when the charging is moved to the night hours. For obvious reasons, people call this peak shaving and valley filling. Now, the most elegant use of smart electric vehicle charging is when it is combined with renewable energy. Let's look at the slide to illustrate this graphically. In figure 1, we see the electricity demand in Denmark for a week in April 2012. We also see the wind generation, and when we look closely, we see that for a few hours there was actually more wind energy generation than electricity demand. The lower part of figure 1 shows what happened to the electricity price during these hours. It became very low and even went negative. Now think about what that means. You actually get paid for using electricity. This is of course great news for electric vehicles. If you can anticipate that tomorrow there will be a lot of wind and solar generation, then electricity prices will be low and charging will be much cheaper. But if lots of electric vehicles are doing this, they are actually filling the valleys that are created by wind energy production. This is illustrated in figure 2, where the gray line show the electricity demand minus wind generation, and the black area shows the effect of lots of electric vehicles anticipating this. Now, an important effect of this smart charging is that, on average, electricity becomes cheaper for everybody. The reason for this is that the whole system is used more efficiently. Figure 3 shows that the electricity costs in the smart charging scenario are roughly 15% lower than in the normal charging scenario. Now, to sum up the beneficial combination of smart charging and renewable energy sources, we see that it leads to lower energy costs for everybody, a better business case for renewable energy producers, and last but not least, huge reductions in CO2 emissions. This is the value of flexible electricity vehicle demand.